Hello learners, you are once more welcome to another session of our program, and today we shall move further deeper into atoms. In our last class we told you atoms are the basic particles that constitute an element. In this lesson we shall look at the atoms inside. In other words, we shall have a glance on the atoms in situ. An atom generally consists of three subatomic particles. We have the protons, the neutrons, and the electrons. Looking at the charge of these subatomic particles, the protons are positively charged. The neutrons are chargeless. In other words, they have no charge, while the electrons are negatively charged. Moreover, the proton and the neutron both have a mass of 1 atomic mass unit, while the electron's mass is negligible. In other words, is considered to be 0. If we look at the location of these subatomic particles, the protons and the neutrons are both located at the center of the atom or the nucleus. Meanwhile, the electrons are found roaming around the shells or in regions called energy levels. I wish to also throw some little light as far as the location or the nucleus and the masses of the protons and neutrons are concerned. If we say that the protons and the neutrons both have a mass of 1 atomic mass unit and they are both found in the nucleus, we are indirectly saying that the mass of the atom is concentrated at the center or the nucleus of that atom. So let us take special note on that. Now let us move further to look at some of the roles of these subatomic particles. The proton generally names the atom's element. In other words, if an atom has 3 protons, then that atom or element is lithium. And if an atom has 4 protons, then we are talking about a beryllium atom. The neutron actually brings about stability in the nucleus, and they also hold the protons in position. Now remember, in physics you were told that like charges repel each other and the protons are all positive. So in the nucleus they should be repelling each other, but that is not the case. So there is a kind of force that holds the protons and the neutrons in place, and that force is what is known as the strong nuclear force. The electrons actually take part in bonding, and of course they bring about stability in the atom. We shall see more on that as far as bonding is concerned. So electrons actually take part in chemical reactions. All right, learners, I want us to have a little evidence on some of the roles of these subatomic particles as well as their location. Before us we have 3 parts: the protons, the neutrons, and the electrons. And we also have an atom here with 2 energy levels or shells. Now if we take a proton and we try to fit it on the shell, we see that it's It's not possible. Let's try the neutron. So it doesn't still go. So the neutron is complaining. That neutron is saying, no, I don't belong here. I don't belong here. Okay, but let us try the center. Let us put the neutron at the center and see. Wow, it's there. It is there. So if we try the proton too at the center, it goes. So the proton and the neutron truly belong at the center of the nucleus. Let us also try the electron. Let's see the electron. Can it be? No, it doesn't. So it rather went to the first shell or the least energy level. Let us also take another electron and see whether it can. No. So the electrons actually went to fill the first energy level, that is the first shell. And let us see if that first shell can take more than 2 electrons. So you see, no. So the first shell or the first energy level can take maximum of 2 electrons. We shall have more view on this in our future lesson. Learners, so you've seen how the location of these subatomic particles are. The neutron and the proton must be in the nucleus. Likewise, the electrons in the shells. So let us see what is happening. Okay, we have 2 protons now. We told you the protons identifies the atom. So 2 protons tells you that atom is helium. 3 protons, we move to lithium. You see, this is lithium. But what do we realize? That atom is unstable. It is unstable. So we need something. We need probably a neutron. So it's still unstable, so we need more neutron. And if we place more neutron, wow, it becomes stable. You see, it becomes stable. So isn't that wonderful? That is that concerning these subatomic particles and their roles, their masses, their charges, and their locations. So from here, let us move to another digital tool where we shall have more fun concerning atoms. Learners, before us we have another digital tool for atoms, and we call it Chem Think. And the first slide simply tells us that chemistry is all about atoms and the way they behave and interact to each other. Now the next slide, we have our pencil, and the tip of that pencil, we are going to see what is happening with the tip of this pencil. And here on the right we have our hand lens. So if we click on this tip, we'll find our hand lens coming, and what do we observe? Lookingly, we have what? Some kind of structures dancing, and those structures are what we call the atoms. So if we move to our next slide, we will try to magnify and observe an individual atom. So let's see what happens. Wow, that is a single atom, and it's kind of spherical, and the edges are what? Fuzzy. Okay, see the edges of this single atom. Now let's move to the next and see what's happening. This is awesome. This is awesome. We see what we call the subatomic particles, some things inside the atom or in situ the atom. And if we move further, we find one subatomic particle at the center, which is called the proton. All right, so the proton is found at the center in regions called the nucleus. That's good. Now, what is so special about the proton? The protons actually, like we told you before, the proton tells us the name of that atom. Now, if we have 6 protons, that is a carbon atom. We already discussed that. And what is so special more again about the protons? The protons, they bring about, they tell us the atomic number. So the number of protons is actually the atomic number of that atom. So take special note on that. And if we look at carbon, this is carbon in our periodic table. The upper number, which is a whole, and smaller number is the atomic number. And down here we have the atomic mass. So we should take special note on that, the atomic mass. And these protons have a mass of 1 atomic mass unit. So we saw that in the table of the subatomic particles. Now, the protons have a charge of +1. So they have a charge of +1. And we move to the next subatomic particle, the neutron, also found in the nucleus. They have what? No charge. They're chargeless, we told you. And true force other than what? The charge attractions, they are capable of what? Holding the protons in position in the nucleus. We told you about that too. So that's so good about the neutrons. And they have what? A mass of 1 atomic mass unit. They have a mass of 1 atomic mass unit. And the last subatomic particle is the electron. The electrons are the smallest. Look at their sizes, they're actually small. Good. And they also are responsible for the fusing nature of the atom. I showed you how the atoms were kind of fusy. The edges of the atom were fusy. So it is thanks to the electrons. And the electrons have a charge of -1. That is -1 there. Now, in a neutral atom, the number of protons equals the number of electrons. So in a neutral carbon atom, if we have 6 protons, we are also going to have 6 electrons. And that is that about these subatomic particles. Now, one last property about the electrons is that they bring about chemical reactions in an atom. They bring about reactivity. They tell us how an atom will react. Okay, that's one feature of the electrons. So that's just a rundown of what we've been discussing. Now let's quickly run these questions. Let's answer them quickly. Now, the protons, what have we learned about the protons? What is the charge of the proton? Now, the proton should be +1. Wow, it goes. What about the mass? The mass should be heavy. I think we can go for heavy. Excellent. The location of the proton should be in the nucleus. Thank you for that response. And role in the atom. What do protons do in the atom? Of course, they determine the identity of that atom. Now let's try to see if they are responsible for reactivity. If we put this, it's going to say no. Let's try. You see, it denies. So telling you that that is the wrong answer. So the protons actually determine the identity of the atom. So we now move to our next slide. Now, what is the charge of the neutron? The neutron is actually 0. It's not virtually 0. However, let's try. So if we put virtually 0 here, we're gonna have it wrong. So you see, it denies. So the charge is 0, and the mass is heavy. Thank you. What about the location? The location should be in the nucleus. What is the nucleus? In the nucleus. Thank you. Role in the atom. So what does the neutron do in the atom? It actually holds together the nucleus. I think that's that. So we now move to the last subatomic particle, the electrons. Now the charge of the electron is -1, and their mass is virtually 0, and the location, electrons are found outside the nucleus. That's it. And the role of the electrons, of course, they are responsible for reactivity. So that's a simple exercise as far as these subatomic particles are concerned. Now we move further to the atomic number and the mass number of atoms. In an atom, we usually have the mass number and the atomic number. The atomic number is also known as the number of protons, or the proton number. The atomic number is the number of protons in the nucleus of an atom. And this number is also equal to the number of electrons in a neutral atom. The atomic number determines the chemical properties of that atom. Now, moreover, moving to the mass number is also known as the nucleon number. This number is the number of proton and neutron in the nucleus of an atom. This number determines the physical properties of the atom, and this is actually thanks to the number of neutrons. I also want to clear a misconception that usually arises between the mass number and the atomic mass. The atomic mass is actually the weighted mean of all naturally occurring isotopes of an atom, and the atomic mass is usually a decimal number. Most of them are decimal numbers. If we move to a periodic table, let's try to see the difference. You see, this is what we call the atomic mass. The atomic mass of cobalt is 58.93. So most of these numbers in decimals are what we call the atomic mass. But the atomic or the mass number or the nucleon number is usually a whole number and is equal to the proton number and the neutron number in the atom's nucleus. So take special note, learners. It's quite interesting to know the difference between these two. Good. So if we come back to our deuterium atom or hydrogen atom, we see that the mass number is 2, and this mass number is actually the protons and the neutrons, while the proton number or the atomic number is of course 1, telling you that since it's a neutral atom or isotope, then the number of electrons is also 1. Good. So we shall move next to our board, where we shall find some IG questions. Alright, learners, before us we have some IG questions, and the first question goes thus: atoms contain electrons, neutrons, and protons. What is the definition of nucleon number? Now, A says the number of protons in the nucleus of an atom. That's not correct. We all know that. B, the number of protons in the nucleus of an atom. That's also incorrect. C, the number of neutrons and protons in the nucleus of an atom. That is pretty good. That is pretty good. But let's not ignore D. D goes the total number of particles in an atom. Oops. So the best choice is C. So I'll go there and I circle my C. Thank you for that. Now the second question: an isotope of iron is shown. An isotope of iron is shown, and that is the iron there. Deduce the number of electrons, protons, and neutrons in an atom of this isotope of iron. Now we know that the upper number, which is the larger number, is always the mass number. I repeat, the larger number must be the mass number. It can be up or down, but note that if it is large, so it is the mass number. So there I'll put my capital A there, and of course the one beneath is Z, which is the atomic number, and this number is always equal to the number of protons and electrons in a neutral atom. Good. So if we go to our responses, if we go to our question, the number of electrons is of course 26. The number of protons is also 26, and the number of neutrons. So how do we get the number of neutrons? We know that the mass number A is always equal to what? The proton plus the neutron. So the neutron will be what? The mass number minus the proton number, which is of course 58 minus 26, and that gives us 32. So the number of neutrons is 32. Now let's go to the next set of questions. Let's go to the next set of questions. The third question says, which statements comparing the properties of electrons, neutrons, and protons are correct? Now, one of the ways we can attack this question is try to verify if the statement is true or false. Neutrons and protons are both heavier than electrons. That statement is of course very correct. So telling us that A and B will be the right answer, so we don't care to look at C and D. The second statement says only electrons and neutrons are charged. That's a big lie. The electrons are charged, very correct, but the neutrons are chargeless. They have no charge. So if A says that statement is correct, then A is wrong, telling us that B is the best answer. So we circle R, B. Question 4 says, a representation of an atom is shown. What is the nucleon number of this atom? Now, the best way we can solve this question is we just need to count the number of protons, which we have positive there. First of all, count them, and then we count the number of neutrons. We know that the nucleon or the mass number is A equals to what? P plus N, which is 6 plus 7. So if we count, the proton number is what? 1, 2, 3, 4, 5, 6. So we put 6, and the number of neutrons we have 1, 2, 3, 4, 5, 6, 7. So we have 7. So 6 plus 7, we have 13. So the nucleon number is 13. We now come here and we circle our 13. The fifth question is for the high achievers, but I'll give you a clue. Now, the diagram shows the atomic structure of an element, X. What is X? So that tells us about identification. And what identifies an atom? Of course, the protons. So the number of protons will identify that atom. Now we just need to count the number of protons in this nucleus, which is 1, 2, 3, 4. So we have 4 protons. So if you don't know an atom with 4 protons, you can just go to your periodic table and you will see the answer there. So you're free to use your periodic table. That's said and done. I want to thank you all for your keen attention. And before we round up, I want us to look briefly on the first 20 elements of the periodic table. Now, learners, in front of us, we have the first 20 elements, their symbol, proton number, electrons, neutrons, and the nucleon number. Now, chemistry demands that you know these first 20 elements, all right, as well as their symbols. And you should also know their proton, electrons, and neutron numbers too. Good. So, from the protons and neutron numbers, you can as well determine their nucleon number, because questions may come in the form of a box where some proton numbers will be given and probably some neutrons number will not be given. So you will use the little arithmetic we just did on our board on some IGI questions to be able to complete your table. So that is why you have to know these numbers. But however, your periodic table will be given to you, so you have no worry about it. Good, but try as much as possible to memorize these first 20 elements and some of their proton numbers in particular. Good. Now these are some of the mnemonics for the first 20 elements, and here he lies beneath bedclothes, nothing on, feeling nervous, nothing, Margaret always sighs. Please stop clowning around kids' canteen. So if you can memorize these mnemonics, where your H stands for hydrogen, He for helium, lithium goes for Li, beryllium, Be, etc., right up to calcium, canteen, capital Ca. This is another mnemonics. So learners, that is that about our lesson. All that said and done, if you find any difficulties, you didn't understand any part of this lesson, feel free to chat me, feel free to lay your comments below the comment box or the chat box, and I will be very much available to aid you, to help you. Thank you and have a wonderful day. Bye bye.